Today I'll be showing how to do AB problem number 13. Okay, it says, account for each of the following observations about pairs of substances. In your answer, use appropriate principles of chemical bonding and/or intermolecular forces in each part. Your answer must include reference to both substances. Part A says, even though NH3 and CH4 have similar molecular masses, NH3 has a much higher normal boiling point of negative 33 degrees Celsius than CH4, which has negative 164 degrees Celsius. And my explanation is, NH3 is a polar molecule that contains hydrogen bonding, dipole, and London dispersion forces. CH4 is nonpolar and only has London dispersion forces. Thus, NH3 has a much higher normal boiling point because the hydrogen bonding forces of NH3 are stronger than the London dispersion forces of CH4. Part B says, at 25 degrees Celsius and 1 atm, ethane, which is C2H6, is a gas, and hexane, C6H14, is a liquid. And that is because both C2H6 and C6H14 only contain London dispersion forces. However, C6H14 has a greater atomic mass than ethane, and that is why it has a higher boiling point than ethane. That should be hexane. Great atomic mass creates stronger London dispersion forces, which increase the boiling point of a molecule. So the bigger the molecule is, the stronger IMFs are. Part C says, Si melts at a much higher temperature than CO2. And that is because Si is a network covalent solid that contains strong covalent bonds, and CO2 only contains weak London dispersion forces. Thus, Si requires more energy to melt than CO2. Part D says MgO melts at a much higher temperature than NaF. MgO and NaF are both ionic solids that contain extremely strong intermolecular forces. However, MgO melts at a much higher temperature because the +2 and -2 charges of MgO are more attracted to each other, creating stronger forces than the +1 and -1 charges of NaF. And that is for AB problem 13.